My name is Simon, and I'm the one behind the Tesla HTTP library. And together with my friend Adam, we founded Ubots, where we build useful bots for Slack in Elixir. So far, we've built 4 products with just 2 developers working mostly only after hours. And today, I would like to explain to you why I believe it could only be done with Elixir and not any other language. So I came to Elixir from Ruby. I started many years ago. I did a lot of coding in different languages, different platforms, but Ruby was really the one that hooked me for a longer time. I think there are many reasons, and there are many different use cases for each language, but Ruby gave this sort of pleasure, and it was just fun to work with. And then when I realized something like Elixir exists, it had the same kind of a flavor of a language built for developers, but also bringing a lot more possibilities than Ruby. So that's the one part. And the other one is that I've always wanted to build something on my own. And I started to think how to build something exclusively with Elixir. So I did some of JavaScript and in general front-end work in the past, and I didn't really enjoy it. I also didn't want to learn mobile development for like iOS and Android. And I wanted to build a business entirely with Elixir. And it turned out that the answer for this question was Slack. And I've always been interested in writing Slack bots. I wrote a few over the years, but most of them were simple, notifications or like simple / commands that did something back in the days. With Adam, we actually built one in 2017 in Elixir, but it wasn't a huge success. 2 years later, in 2019, we noticed that Slack expanded their API. So today it's no longer only a chat application where you can send messages and use kind of cryptic / comments, but you can open models. You can use very rich forms with lots of different controls, like text inputs, selects. You can upload files, and you can even have a dedicated page for your app inside the Slack application, which is called the Home tab. It all leads to great user experience for people using your bot, because they do not need to leave the Slack application and go visit some third-party website. So they can stay inside Slack and do everything in there. And the best part of all that, all those possibilities that Slack is giving, was that all you need is JSON. So suddenly, when the whole user interface can be defined using only JSON payloads, a developer became a designer. And the biggest obstacle that I didn't want to do, for the reason that I didn't want to build a web application or mobile application, suddenly disappeared. Obviously, the Slack UI is very limited, so it was quite a challenge to build everything that we wanted. It also required some smart hacking in some places, but in the end, it was a very big satisfaction, and it is still today. So as I mentioned, we have today 4 bots, and as you can see, I'm still a terrible designer. We now have 3 people. There's the Adam that we started with, and that we're still the only two developers here. And we have been joined by Camille, who is now taking care of marketing and helping out with other operational stuff. So why we succeeded, like why we made it to build 4 products with just 2 people with very limited time. And I think there are a few key reasons for that. Is that we didn't quit our jobs. We didn't move to Silicon Valley. We didn't raise any funding. We took it small. We did it step by step. And what we did is that on the business side, we charged money from the very first day when we released it to public. And that was a huge difference. And it changed our perspective that we're no longer working on a side project for fun, but now we have a business that people are using and that people are paying for. This really changed everything and how we approached it. And the second thing that I'm going to focus today on is that we chose Elixir. And I've already mentioned that for me, Elixir is very similar to Ruby in a way that it's just a fun language to work with, but it's not only about fun, it's really super productive. So we started not very seriously, to be honest. Like, we just wanted to write some bots and see what it goes. We didn't plan on making it our, the day-to-day job back then. But we've noticed that despite not putting that much time and with such a tiny team, we made a big progress. And that's when we realized that, it gave us a huge motivational boost. Like, this is the ecosystem that we can really do something great with not much resources. And comparing that experience with other languages and platforms, I think that this is really the best you can get. And there are a few reasons that come to this realization. Is that one is that Elixir is extremely stable. Like, we had no issues during development, no issues during deployment, no surprises really. And no cases of you open the project and suddenly something updated and now everything is broken and you spent hours Googling for error messages, checking Stack Overflow. This doesn't exist in an Elixir world. The updates are super boring, actually. So we started with 1.9 and now we're running 1.11. Updating to 1.12 will be probably as boring as it was before. And that's also my experience with Tesla. I'm starting with Elixir 1.0 actually, and now it runs 1.11. No big deal over the whole 5 or 6 years. So this is, from a business point of view, this is an amazing thing, because you know that your developers, and me actually, also, it's not going to waste time on meaningless work just to make things going. Elixir is like super stable. And in a previous talk, Peter mentioned that everything can change, and your business logic can change, the world can change. And I agree, that is true. But also, you can count on Elixir and the ecosystem that it will become stable, at least in the short middle term. And some people are asking about Elixir 2.0, and there are no plans for Elixir 2 currently. And I'm actually a big fan of that. So that the Elixir team is working on improving the language gradually, but not making any big changes that suddenly everyone has to migrate. Elixir has also one of the very best tooling you can ever have of mix hacks. We have this live reload and mix watchers that just reduce interruptions while it works. So you can actually just slide in, and you have 15 minutes and you're instantly productive and you can code a new feature. I'd like to also highlight the Elixir language server and its integrations. I'm using it with Visual Studio Code, and it's been really great. Especially the rapid dialyzer that just gives you feedback before you even try to run your code. So now that we have great tools, how to actually structure something like 4 products just with 2 people. So because we are just 2 people, and not 100 developers, big company, we decided to go with just one majestic monolith. So we have one repository, one OTP application, and that we generate just single release, put it in a single Docker container, and just have a single deployment of that. What's not that usual is that we used top-level modules. So we have the standard separation between your app and your app web, which in our case is the core and the core web. The core web takes care of the HTTP stuff. Core is the common code that's in our bot framework and everything else. And then for every product, for every bot, we have a separate top-level module and a different tree of files that contain all the logic, and they do not interact with each other, but they still live inside the same code base and are deployed together. And this allows us to simplify everything about this. And one might think that building a monolith might be slow, but actually Elixir is great. And we have 21,000 lines of code, of library code, and it's compiling in over half a minute. And we also have 10,000 lines of tests, and they run in just 17 seconds. So compared on your background, this can be either a lot of code that runs super fast, or not that much code that is underneath for products. So both ways, I think that's a huge win. Now I'd like to peek a bit under the hood on what's really inside. So we're using a boring stack, which is a standard Phoenix Elixir Postgres, just with Open, Redis for caching, and Node.js. And we are not really super smart here. We are using old patterns just with a new kind of a framework. So the way Slack works is that for every interaction, it will send to your application HTTP requests. But these APIs are not very consistent. The payloads are different, the formats can be different, and we didn't want to deal with that in every single bot. So instead, we built an abstraction on top of that. So instead of plug connection, we have a context, which is just a data structure. And instead of a random params map, we parse that into a well-defined structures that represent the UI actions. And more to that, we also have some kind of middleware, some controller and view layer that I'll get into in a moment. And like why Elixir was so great, and why I think we couldn't do it in any other language. And there are a few cases for that. So one is that Elixir allows you to write a pure functional code, so the code that has no side effects. An example of that is all our view layer, which is basically a modules with pure functions that take some arguments and return a data structure. And we can test it easily without mocking the whole world. We can test that in parallel because these are just pure functions and they don't call anything else. And it's super easy, especially for complex view that have many variants depending on the parameters they would get. But also, that's not everything. So in Elixir, you can also write impure functional code, which is still functional, but it allows to do some side effects, some IO operations. And it's for me, after working with a little bit with Haskell and other pure languages, I think the Elixir is like the sweet spot of functional programming where you can do actually both the pure and impure programming. And one of the examples where we use that is the middleware layer, where it's still a function. It still takes a context and action and returns a context, and that fits into the pipelines. But inside, we can use stuff like Logger or whatever else we want. And this does not break the thing that this is still a nicely composable functional code. Another feature that we use really a lot is pattern matching. I think like 70% of the code base is based on pattern matching. And as I mentioned, the payloads that come from Slack can be very different. And we could probably write 1,000 if statements if you wanted to find the logic on how to parse that. But instead, we can use pattern matching and simply define like, hey, if we see something like this is a comment, and something other, this probably is a shortcut. And this works very well. So you can define define your functions as different clauses, and it's very, very readable, and it's easy to add more to that. Like if there is something new that we need to support, we just add another clause. But for me, the interesting part here is that the pattern matching is very human. Like we as humans, we work with patterns, we recognize patterns, and we use that to learn. And here we can just simply express that our human behavior in code. We also use pattern matching for routing. So our bots consist of many controllers, and we, instead of routing by path, because we have only one HTTP endpoint, we simply match the actions inside controllers, and we group them by functionality. So we can like match buttons and commands related to join operation in one place, and leaving operation in another place. We also use some macros, but just a little bit. I know macros may be a controversial topic, but I still think that applied in the correct amount can bring a lot of value to your project. We basically stole what Plug does with pipelines, and what Phoenix does with the endpoint. And we built something similar where we can have both middleware and controllers. This could be done without macros, but it just looks much, much nicer this way. And the macros are not that hard to understand. We also use some macros to do not repeat ourselves. In this case, we have this def action macro, which basically defines a module, and inside a struct with a type, and as a bonus, a compound top-level type of all the structs as a union type of all these structs. This is, again, like, you don't need to do this. You could write that by hand, but because we have a lot of these structures, it was really it really helped to just keep it readable and make it easy to add more and more. Obviously, it's not an Elixir talk if you don't talk about processes and OTP. So here we go. Apart from the great performance, the multi-call usage that leads to low resource requirement, Elixir makes it trivial to perform asynchronous operations. If you just need to parallelize something or make few thousand API calls in parallel, you can do that easily. We also have, thanks to the OTP and supervisions, features like self-healing and fault tolerance built in. And the best thing about this is you don't really need to worry about this. So some people I've talked to who were learning Elixir were put off the first time they read about PIDs, like the supervisors, gen servers, and all of that. And the best thing about what Elixir did to Erlang is that it kind of hide the complexity. Like with tools like Phoenix or Open, you don't really need to know and be an expert of processes and supervisors to get advantage of these tools. And that's also the great productivity boost for Elixir, that like you don't really need to know. But if you want, you can really unleash the full potential of Elixir. So, and for example, build something like end-to-end testing framework for Slack bots, which we did. And this is an example, a real example from our code base, where we basically build a testing framework. We can say like there's some user, there's some Slack channel, and then you write a scenario that the user goes to the channel, executes a command, clicks a button, and then we can assert that some phrase is visible in that specific channel. And while I mentioned we use a lot of unit testing for the pure function, we also needed a way to test complex interactions with multiple users in multiple channels, also users from multiple Slack workspaces, because Slack now has this Slack Connect, which allows collaboration between workspaces. So we needed all that. And instead of mocking the APIs in an ad hoc manner, we decided to build something else, and we base that on Elixir processes. So we have a single gen server that keeps all the state and is intercepting all the in and out communication with Slack. So like when we have the DSL that like go to channel, this is or comment or click button. This is all just sending messages to that single gen server, and then it will call our Phoenix endpoint and all the way down to the bot code. And on the way back, when we need to send, when normally we would send an API call to Slack, we just swapped the Tesla adapter for our own in test environment, and we call the testing server again. So the server knows how to process that message and, for example, update the state of the model that user is currently seeing, so that we can then assert that this really happened. It was a really fun project, and I can't stress enough that I don't know how this would look like, how to implement that without all the tools that Elixir gives us, because we ended up with really elegant solution that I hopefully could explain in just less than a minute here. Also, I call this end-to-end testing, but note that this is just all backend code, just JSON in and JSON out. If you're interested in end-to-end browser testing, there's a session tomorrow, so be sure to check it out. And one more thing that is quite important that came to me after some time working with Elixir is the refactoring part. So we know that version 1 or version 0 is usually always bad. Like we need to try out the ideas. We need to see what works, what doesn't work. And often we need to write the V2, V3 or whatever. And we need to move things around. So in Elixir, since everything is just modules and functions, and we use aliases and imports that are checked by compiler, it's super easy to move things around. Like you can just literally copy and paste code from one place to another, maybe update one or two references, run a compiler, see if anything is broken, run a dialyzer, see if everything is broken. If not, you're like 99% confident that this will not break. And we even had two versions of the bot framework, the V1 and V2, at the same time, at the same code base. And we just moved products, our bots one by one from V1 to V2. And after we moved everything, we just renamed some modules, and it was really not a big deal. And also, quite an important thing that we have learned the hard way is that you can very nicely organize code in Elixir using modules. And the first version of our testing server was using actually multiple processes. We had process for each user, for each team, for each channel, and we ended up with a lot of code just to communicate between these processes. And we did that separation because we ended up with just a lot of code related to users, a lot of code related to teams and channels. So we wanted to organize that. But that was a bad idea. Processes should not be used for code organization. And now we are back with single process that handles the communication and makes everything work. But we do delegate to different modules based on their scope. And we just do that with by prefixing messages and then delegating to other modules that still operate on the same state. And the last thing about Elixir, which is super great, is the great community and smart people. All the GitHub issues, the GitHub contributions that you can see, the Elixir forum, podcasts, blogs, and obviously conferences like this one, it has been really, really great. Whenever we had some problem and stumble upon something we didn't know how to do, we could find an answer provided by the community. So the question really is, like, is this really only possible with Elixir, like all that? And I think yes, like 10 out of 10 boxes say it is. And someone might argue that obviously technically you could do the same in any language. Probably yes, but I really wonder if that would be possible with just 2 people working after hours on 4 products and delivering, what ended up being a profitable business. And basically, if we could do that with just 2 people, imagine what you could do with a bigger team. Thank you for listening. I hope you enjoyed the talk. Be sure to check out our bots. I'm also working on something new, so you can also check it out. Follow me on Twitter, and I think we still have some time left for questions.